Hi, this is Tim Fox, and I'm here to talk to you about LSTMs and RNNs in BigDL. And so this is the fourth part of a 4-video series, which is introducing BigDL and showing you some training examples here for BigDL. A little about me. I'm a data engineering and data science practitioner and a partner and principal at Elephant Scale. At Elephant Scale, we do training in big data, AI, deep learning, and machine learning. And I'm an author of Data Science in Python on LinkedIn Learning and an open source contributor to projects such as BigDL. Note here the GitHub repository that we're using for this today. I strongly encourage you, if you have not already gone through the earlier examples 1 through 3, I encourage you to do that because that'll explain how to get set up and how to go ahead and get to all the examples and everything that we have here. We are going to talk about this example today, and we're going to actually look at 2 examples that are based on LSTMs and RNNs. Before we get started, let's talk about what LSTMs and RNNs are. So RNNs stands for recurrent neural networks. And so basically, that is a type of neural network in which we are not feed forward. So we have some of the direction can feed back. And that can do a lot of different things for us. One of them is which allows us to store memory because it enables us to be able to maintain state and do a lot of other interesting things like that. LSTMs are a way for us to have a memory cell in our recurrent neural network. All right. Now, I'm going to show you some examples here. So we have 2 examples we're going to look at today. First one is LSTM 20 News, and the second one is LSTM Stocks, both of which are under the directory Work Notebooks in the BigDL training repository that we saw here before. Let's first look at the LSTM 20 News here. We have the 20 News group classification problem is something that you'll see here as one of the examples with BigDL. And in fact, BigDL includes some helper classes in order to help us do that. So what is the 20 News group classification? So basically what that is that it's just a data set which has some largely plain text input of some scraped content from Usenet news groups. And there are exactly 20 different news groups that are represented here. So what we're going to do is we're going to look at how we can use an LSTM in order to perform that problem, doing the news group classification. Now, some of you are probably going to ask, that's great, Tim, but why are we using an LSTM or any kind of RNN to do text classification? Is it really needed to do that? And I'd say the answer to that is no, although it is probably worth a try. We certainly could use a convolutional neural network. And in fact, if you look at the examples, we have an example built into BigDL of using a convolutional neural network in order to perform this problem. However, it is interesting to also try using a recurrent neural network on this. It certainly can't hurt. Now, in the second example, I'll show you an example which is a bit better suited to LSTM strengths. Okay, so let's first start out, though. We're going to do our imports, and here that we have, we're getting the News 20. We are dealing with plain text data here. What we're going to do here is we have some helper functions that will enable us to go ahead and convert that text, for example, to words. We're also going to look at this where we're going to say analyze text. We're going to be calling that here. We also are going to call pad, which is going to help us to pad our data. And finally, we're going to have this function here called toVec, which is going to go ahead and convert the data to a vector. ToSample is going to use our sample format that we use in BigDL as in order to convert the vectors here to sample format. Okay. Now let's look at the model. The model, as you can see, is a recurrent neural network. So notice before, this is something new. We haven't used recurrent neural networks before. And we are going to add an LSTM layer there. In addition, we're going to add in a linear layer followed by a softmax layer. Now, the softmax layer, of course, we have because this is a classification problem. We're going to be doing that as well. So here's our model. We are going to need to train our model. And so let's look at what we have here. So we're going to be using learning rate 0.5. The batch size here is going to be 128. And we're also going to do this for 30 epochs. Not really enough, but for a short example that shows you the idea. What we're going to do is we're going to go ahead and get started. So what we're going to do is we're going to get our news data set here. As we said before, we have to convert this into vectors. And so to do that, we're going to use an embedding called GLOVE. So GLOVE is a type of model that is designed specifically for feature extraction of natural language. Similar in some ways to Word2Vec, not the same model. It's a totally different model, although it's similar in the sense that it can take data and extract features in terms of into vectors. You can look more about GLOVE on your own if you're unfamiliar with it. The important thing to note here, though, is that we're going to be using this to create vectors from our natural language. Then we're going to go ahead and we're going to create RDDs out of this. Notice here we're going to start out by tokenizing our data. Then once we have tokenized, we're going to create vectors. And then we're going to convert those into samples. Now, so far, we haven't really done anything that's specific to LSTMs. This is basically just talking about doing the feature extraction and of our natural language data. So you can follow a similar pattern on your own if you're planning on using natural language data. So now it's time to do training. So what we're going to do is we're going to first split up our data into training and test. Then we're going to use the optimizer in order to actually train our model. So we'll go ahead and do that. We're going to build this model here, and we're going to call it with our 20 classes that we're going to be using, and that's going to go in and call our build model that we saw before. We're going to go ahead and set up our training parameters. We're going to be using AdaGrad here. We're passing in our learning rate and our learning rate decay. We're also going to set our validation here. So we're going to check our validation and look at our accuracy here as well. Okay, so we're going to run this and set this. Now, it will take quite a bit of time and memory to go ahead and exercise this. So make sure you have running this. If you're running in the notebook, you're running on a big machine with plenty of juice. So, and you might probably also want to up the Java heap space. Well, what if you don't have that? Well, one option is to actually convert this into just a Python file rather than a notebook. Okay, it's going to take some while to run this. I'll run this, and then we will follow up in a minute. Let's actually now look at the next example. The next example is, so we ran here, by the way, we trained the model before, and okay, so I'm going to show the next example here. The next example here is called LSTM Stocks. Now, we're going to look at the S&P 500. So basically what we're going to do is we're going to take historical closes of the S&P 500 and see if we'll be able to predict the stock market. Now, just so I don't get in trouble here, I'm not actually recommending you make any actual trades on this. In fact, if you see the results of the model, you'll see it's quite simplistic and not anything you would want to make trades on with your own money, to be sure. But again, that's what we're going to be doing. This is the kind of thing that we certainly could build some models for making financial predictions, although it's going to likely be much harder to do that in real life than what we're doing here. So let's load our libraries here. We're going to look at some training parameters as well. So we're going to load the S&P 500 data. So now we're going to load it from a file, and this file is going to have on each line a close of the S&P 500 on the given day. So now notice we don't have a date or anything else. Now we're just going to assume that we're looking at, it really doesn't matter actually. We're going to assume that we're looking at the dates. I believe it is closes. So we're just looking at closes, and every close represents a new day. Now, we don't really care exactly when or how or what this comes from. Really, we're just looking at this as a sequence of numbers, right? So, in other words, we're seeing a sequence, and what the goal of the model will be is to try to predict the next patterns in the sequence, right? So that's what we're going to do. If we want to go ahead and look at the S&P 500 data, let's just look at that real quick. So that's the kind of thing that it looks like if you see that there. Okay. All right, so let's load the data here. And so I'm going to be loading our data here. Okay. And I'm going to put this in X train, Y train, X test, and Y test. So what that is that we're just going to already load that data with a helper function here, and we're going to put that in X train, X test. Now, next step is we're going to take those and put that in RDDs. So now, clearly, we've seen this before. We are going to be able to need RDDs, and ultimately, actually, what we're going to need to do is we need to put this in sample format. So actually, what I'm going to do is I'm going to go ahead and do a map on my RDD to convert this into X-train and X-test sample. Okay, and I'm also going to take the Y-train and Y-test there. Now, in this case, X-train and Y-train, we're talking about the X being the input variable, which is the S&P 500, and Y is going to be the output variable. Okay. Now, we're going to build the LSTM. So what we're going to do is we're going to use a recurrent neural network, as we said before, and we're going to go ahead and add an LSTM layer. Then we're going to finally add in a linear layer as well. So now, we'll look at the shape of the model. So we're using a model which has 50 inputs and 1 output. Now, why is that? Well, we're going to see clearly in a little bit why 50. Actually, that number is fairly arbitrarily chosen. The output being 1 is something that is because we are going to predict exactly 1 output. Now, you might ask, well, if you're trying to predict the stock market, don't you need to predict more than 1 output? Well, yes. And we'll see exactly a little bit later how we do that. But in this case, we're going to look at exactly 1 output. Now, the 50 here is just a number that I chose because we're going to be looking at windows, sliding windows of data. And we just chose 50 arbitrarily as a good number of data that we're going to look at. Okay. Here, it's time to train the model. So now, this is going to be a regression model, not a classification model. Now, that's important because we're not using a softmax layer, and we're not going to be using cross-entropy as a verification as we did before. We're going to instead be using a MSE, or mean squared error, because it's a regression problem. We are trying to predict the value of the stock market next, not say whether it's going up or down or whatever kind of classification problem we could dream up, right? The point is it's a regression problem, and we're going to use and train our model on that. It's going to take some time to train, so I'll pause here for a second. Let's actually look at the results. Now, what we're going to do is we're going to go and we're going to start making predictions. Now, remember, we predict exactly 1 output from inputs. Now, that's not necessarily going to tell us too much. What we want to do actually is we want to kind of predict the market going forward. But we're not going to try to actually predict the entire sequence because that's too much. So how do we do this? What we could do is we could throw in a bunch of values, 50 to be exact, and then just have it try to predict future values after that. But one thing is we only are able to predict 1 sequence in the future. But we want more than that. We want to be able to predict maybe a whole window. So how do we do that? Well, let's look at this. What we're going to do is we're going to take, remember, our prediction is going to be 50. So we're going to take a window of 50. And what we're going to do is we're going to iterate through our data. And essentially, I'm going to create a frame of 50. So, and remember, we have 50 as our number of input neurons. So we're going to go in and take that. And then what we're going to do is we're going to produce an output. Then we're going to go ahead and move forward 1. Taking the next value, the predicted value, as the next value in the sequence, and so on and so on. And we'll continue making a prediction lengths that are also of 50. So what we're going to have is we're going to have basically a sliding window in which we're going to take 50 inputs, and then we're going to go through and we're going to try to get a sequence of 50 predictions. And we're going to do that on several occasions here. So let's go ahead and do that then. And now this is going to take quite a while to run. So we'll go ahead and run this. Okay, so let's go ahead, and what we'll do is we will look at some of the results here. We have our actual S&P 500 data plotted here. And then what we're going to do is we're going to look at a sequence of 50 results. So let's take this for example here. We take some of the outputs here, and then using our model, we're going to go ahead and use a prediction here on where we're going from here. So notice that in this case, the model is usually predicting the stock market's up. It's a very optimistic model. Now we could look at that a little bit more, kind of play with that, but you can see the idea here is that we're going to go through forward, and then we're going to look at the trajectory of the 50 here, and so on and so on and so on. So you can see the results of what we have. So I'd encourage you to go ahead and look at this further to see if you have if you can tweak the model. There's actually some very interesting things we could do here. But nonetheless, I wanted to show you kind of how this works. Now, why is LSTMs and recurrent neural networks important in this case? Well, we're looking at sequences here, right? And so in this case, the value of the S&P 500 isn't merely a result of the inputs, right? It also takes into account state. And so that's why having the LSTM is going to be very helpful in maintaining that, because the reality is that what we're looking at here is going to be less of a input to output and more of a sequential operation, which is going to be, a bit like a Markov chain, right? In the sense that our result on our S is not going to be simply a result of the inputs statically, but also as a result of the state as we go along. And the LSTM is going to help us do that. Now, not saying we couldn't work this problem without LSTM, but that's going to be something that we have. That is all I have for this one. I hope you have a lot of fun looking at LSTMs and RNNs and see that there's a lot of things that we can do with BigDL. And there's a lot of different types of models and other things that we can do. I hope you've enjoyed this 4-part series about BigDL. I want to conclude by talking about what makes BigDL so powerful. It gives us Scala and Python support. Now, you've seen us demonstrate a lot of these examples in Python. And of course, Scala, the native language of Spark, is also supported. It integrates with Spark ML and Spark streaming. So that gives us some powerful interactions with the rest of the Spark framework. And that's one of the main advantages of BigDL. It gives us easy development. We're using Jupyter Notebook, as we've seen in this last example. We can visualize using TensorBoard, and we can help fine-tune Caffe, Torch, and TensorFlow models. And we've seen that in video number 3. So here's 4 reasons why you can get started with BigDL today. You can analyze your big data using deep learning on the same cluster where your data is stored to avoid data transfer between separate systems. So where's your big data today? It may very well be in a Hadoop ecosystem or other related big data tools. You may be analyzing that with Apache Spark, and you can use BigDL for that. You can also build E2E analytics pipelines using big data frameworks, including deep learning capabilities, and to reduce system complexity and the latency for end-to-end learning. One of the shortcomings of a lot of the big data ecosystem frameworks that we're using today is their lack of deep learning capabilities. And so BigDL solves that problem. It gives us a state-of-the-art deep learning capability that runs natively on top of the Apache, Spark, and Hadoop frameworks. Also, we can reuse our big data clusters for running deep learning workloads, and then those can be dynamically shared with other workloads. Finally, when we use BigDL, it'll simplify deep learning and accelerate our AI innovation. So I'm excited about what BigDL has to offer. I think that you'll be excited about it too if you give it a try, and hopefully these last videos have given you a chance to do that. I'm very happy to be a part of the BigDL project. Please don't hesitate to get in touch with me if you have any questions. I'd love to work with you to help you with any of your deep learning challenges on Apache Spark and with BigDL. Thanks a lot.